In lesson 3.1.4, we're continuing our study with similar shapes and connections with dilations. And in problem 37, it has you start off by looking at the picture and then reading the math notes box in the section to see how to write a similarity statement. So that's what I want to go over. So just real quick before we kind of define a couple things. The right angles are marked with boxes. So angle B and angle X, those are equal angles, congruent angles. Angle A has one tick mark, angle Z has one tick mark. So angle A is congruent to angle Z. I believe in the book they have double tick marks in C and double tick marks in Y, so angle C is congruent to angle Y. I just didn't draw that because if those two are equal to these two, that means angle C has to be equal to angle Y. So anyhow, you're supposed to read the math notes, so you can definitely skim those math notes, but I'm kind of highlighting to have a similar shape. It means you have the same shape, but it's a different size. And we learned how to dilate. Dilation is the transformation that causes similar shapes. So every time we deal with similar shapes, it is some form of dilation. So it might grow, it might shrink, it depends on the factor. This is the similar symbol. You need to know it. So similar is one little squiggle. Remember, just a side note, for a shape to be called congruent, it has to be equal to another shape. And the symbol is a similar squiggle with an equal to bar. So that's congruent. Similar is just one squiggle. Okay. All right, for similarity statement, this is from the math notes box. What you do is you line up all the corresponding sides of the similar shapes and you match the corresponding angles, and they have to be in the same position. So for instance, if I call this first triangle triangle A, B, C, there is only one way to write triangle, the other triangle, to match the A to B to C triangle that I started with. So angle A we said was congruent to angle Z, so Z has to go first. Since A went first, Z has to go first. And then I went A to B. A to B, this side right here corresponds with Z to X. So X has to go next, and that leaves me with C and Y, which we already said that they were congruent angles anyhow. So C has to be in the same placement as Y. Here's just another example. You could name that first triangle CBA. And then you have to reorganize your letters over here. So it would have to match. C is congruent to Y, so Y has to go first. C to B is corresponding to YX, side YX. And then B to A corresponds to X to Z, so Z has to go last. And then I always check the angles. C and Y are equal, B and X are equal, and A and Z are equal. So we got it right. Okay, and there's lots of different orders. You just have to make sure you match up your second triangle the same that you did the first. All right, and then continuing, they give you another set of triangles that are similar. And the first part A says to write the transformations that could take one triangle onto the other. So similar shapes mean, if shapes are similar, that means there is a set of transformations that you could make on one to turn it into the other. So this one, what I said was reflect over a vertical line between the triangles. So if I flip that little triangle over top of this line right here, it would land over here. I might have to throw a translate in, maybe, and then I put just dilate, because I know this guy has to grow in order to get to be that size. So if I reflect it over the right line, it would actually land on top of this, and then I could just do a dilation. But if you had to translate, that would be fine also. All right, part B gives you 4 options and says which of these are true based on the information above. So let's check them. So D to O to G, D to O to G. So that went down the middle. D to O is the middle length side and O to G is the small. So we have to do middle side to small. The middle side is 16, the small side's 10. So that would have to be labeled C to T to A. And that is labeled CAT, so this does not work. All right, let's try this number 2. They did dog to CTA. DOG, so I just checked the first two. D to O is the middle and O to G is the short. So I have to do middle to short, so I'm going to go C to T to A. C to T to A, this one works. And then number 3, OGD, OGD, that's short to long. So I have to go short to long, so that's T to A to C. T to A to C, nope, wrong. Let's check this one. DGO, D to G to O, so that's down the long, down the short. So we got to go down the long and down the short, so that's C-A-T. Perfect. This one also works. And there's others that work, they just didn't put them as options. And then this is not in the book, but I just made up one practice problem because I want you to see how you can actually utilize the similarity statement. So this is called a similarity statement when you state two triangles are similar. And so I just made this up. So it says solve for A, the shapes are similar. So here's the similarity statement. We need to figure out how to find missing length A, and the triangles don't look the same. So in the last picture, they were really nice and they made the triangles look pretty much like one is a dilation of another. Same thing up here. One of these is dilated to get the other, you can tell. But on my picture, I'm really mean and I didn't make one look similar to the other. They actually don't look like they're similar shapes. So what I'm trying to make you realize is you can't go by looks. So what we do is we use the similarity statement. So you know you have to find A, so that's WY. WY is the first and the last letter up here, which means that's going to correspond to the first and the last letter on the other one, so MK. So MK, this side, corresponds to A. So I use proportions to solve these, so I'm going to go ahead and just set up a proportion. I'm going to put A, the ratio A divided by 18. You can do 18 over A, it doesn't matter. Either or. Has to equal, and now I have to be careful because I have to find which side corresponds with 10. So I have a 10, but I don't have this side. So we have to see what side corresponds to ML. So go up to your similarity statement. M and L are the first two letters. So I have to do the first two letters over here, so that's WX. So WX is the side that corresponds to 10. So 10 and 4, so I did A over 18 here, so I have to do 4 over 10. On the bottom, I did 18 over A, so that would be big over small, so that would be 10 over 4. Both of these will work, and there's actually other ways that you can set them up too. And then you can cross multiply, or you can fraction bust, however you do it. So let's grab this. We get 10A is equal to 10A is equal to 72, and then divide both sides by 10, and that gives you 7.2. So A is 7.2, and this would solve the same. So what I wanted to do is just make sure you see how you can use the similarity statement even if the pictures don't look correctly drawn.